Okay, so we have a bunch of unit conversions. You should know the unit conversions. So if we're going between moles and number of particles, what is the unit conversion we're using for that? This thing that started this whole chapter, that big honking number up there, it's Avogadro's number, okay? Because the conversion is 1 mole is 6.02 times 10 to the 23 particles, or you flip it. 6.02 times 10 to the 23 particles is 1 mole, depending on what you want to do. Then, so that was Avogadro's number. The second thing we did is we did moles and mass, right? Going back and forth. That was the molar mass, which is in grams per mole, or depending what you want to solve for, 1 mole is the molar mass, mm, in grams. Right. Oops. is molar mass. That will be the abbreviation from now on. And then we did moles and volume, but remember, this is what we just did. That is for gases only. It is not liquids and not solids. Okay, so it's gases at STP, and that was, can't write in highlighter. 1 mole occupies 22.4 liters, or 22.4 liters is 1 mole. And then this one is kind of sort of baked into some of these molecules and atoms. It's basically like, that's if I say chlorine, actually, say sulfuric acid, H2SO4. 1 mole sulfuric acid, how many moles of hydrogen are there in there? 2, right? It's double, because for every molecule of this, you have 2 hydrogens and you have 4 oxygens and 1 sulfur. Okay, so these are, we're going to start to add this in. So that is just using this conversion, number of atoms for 1 molecule. Or, obviously, you flip it, 1 molecule has a certain number of atoms. So that's going to change depending on which molecule we're looking at, or which chemical formula we're looking at. Okay. Pretty much every question, you're going to run through moles at some point. Okay. So I don't like this one. If we go to, or you don't have to go to it, you can just look here. This is 2 pages from there. Conversion pathways. If you want to go from mass to volume of gas, you have to run through moles first. Okay? And then once you get moles, then you can split out into anything. So almost every question, the first step is you're going to convert to the number of moles. We always want to know moles in chemistry. Okay? I won't say always, but most of the time you want to know the number of moles. So if you don't have any clue how to answer some of the questions, convert to moles instinctively. Okay? All right, let's just do some multi-step pathways. Now, me and Mr. Booth do things very similarly, but this is sort of where we sort of differ. Okay? When he is doing these calculations, he likes to make a plan. All right? What are you trying to figure out? Mass, then you're going to go to moles, then you're going to go to volume. I don't do that. I just sort of let the math take you where you're going to go. Okay, and that's the way I've sort of been teaching you. I just look to cancel units. That's all I'm trying to do is cancel units until you get to the units you want to do. All right. So if we have 50 grams of ammonia, NH3 at STP, and remember, please put your units and especially put the chemical that you're using or that you're dealing with. Now, for these questions, it's only going to be one chemical, but in the, I don't know if it's the next unit or the unit after that, we start to look at reactions, the chemical will change. Okay, so writing NH3 is important. So we have 50 grams of NH3. I'm trying to get the volume. I need to get rid of the grams. What unit do we always want in chemistry most of the time? Moles, right? So I have to get, I know that there has to be grams here, right? And moles up there. So grams of NH3 and usually moles of NH3 there. Okay. Moles per gram. Or 1 mole is how many grams? What am I looking for here? Molar mass. So NH3. I got 1 nitrogen and I got 3 hydrogens. What does nitrogen weigh? You'll need your periodic table. 14.0, and hydrogen is 1. But we have 3 of them. So it's 3. So what's the molar mass of ammonia? 17. It should be 17.0. You're right. 17.0 grams per mole. Okay. This is the molar mass of ammonia. Where do I put it? Where does the number 17 go? Top or bottom? Bottom, right? Because it's 17 grams for every mole. So that means 17.0 grams is 1. I don't have to write it that far away. Is 1 mole of ammonia. Okay, so now the grams has canceled. I'm left with moles of ammonia. I want volume. What do we measure volume in? What units? Liters. Volume is measured in liters. Okay. Of our conversion factors, there they are right there, or you can look in the table that we just wrote up. Which one has moles and liters in it? Liters, moles, liters. Okay. Which one do I want to use? What unit do I want in the box here? Moles. In the bottom one, I want moles, right? Because I want them to cancel. You want liters up top. So I want 1 mole of NH3 is 22.4 liters of NH3. So the moles cancel, and I'm left with liters of NH3. Is those the units that I want? That's what you also have to ask yourself. Is that the units I want? It is, because I want volume. So you multiply the top, you divide by the bottom, and you're going to tell me what you get for an answer, please. Sorry? No. Cosecant squared or something. How many sig figs should your answer have? 3. 65.9? Is that what we get? Okay. All right. Now we're going to convert atoms of chlorine. What is the mass of that many atoms of chlorine? I don't know why you'd want to know that, but we're going to figure it out. Okay. So 1.00 times 10 to the 12 atoms of Cl. Which of our units has atoms or particles? Atoms are the same as particles. What are the only ones with particles? Yeah. It's Avogadro's number, right? Particles are the same as atoms. So I want atoms in the bottom there. So that means there are 6.02 times 10 to the 23 atoms of Cl in 1 mole of Cl. Atoms cancel. Now I have moles of chlorine. I'm trying to get from moles to, what am I trying to figure out? Mass. What unit is mass in? Grams, right? This is grams. So I need to convert from moles to grams. Which one am I using? What do I need to figure out? Molar mass. What's the molar mass of chloride? I know this is super exciting, people. There we go. 35.0. So that means 1 mole. 35.5? Yes, that is correct. I was just checking. It's 35 grams of chlorine. So moles cancel, and then you're going to tell me the answer, please. What's the answer? (5.90 times 10 to the minus 11). That's what you said? There you go. And 3 sig figs because we had 3 in our beginning, and the rest of them are basically infinite. Okay. Okay, last one. Here we go. How many oxygen atoms are in 75 liters of SO3 gas? Oxygen atoms. So 75.0 liters of SO3. Which unit conversion has liters in it? The 22.41, right? So, do you want liters in the top or the bottom of the next one? Bottom, because you need them to cancel. So 22.4 liters of SO3 is 1 mole of SO3. Okay. I have moles of SO3. I now need to know how many, what unit conversion am I going to use next? Particles. I need to know particles of SO3, or molecules if you want. So that means 1 mole of SO3 is 6.02 times 10 to the 23 particles or molecules of SO3. So now I have particles of SO3, but what am I actually being asked? Oxygen atoms. How many oxygen atoms are there in 1 molecule or particle? 3. So that means there are 3 oxygen atoms for 1 particle of SO3. So now the SO3 units cancel, and you're left with oxygen atoms. And I want you to please type that into your calculator and spit out the answer. 24? And that's what I got. 6.05 times 10 to the 24 oxygen atoms. Okay, 3 sig figs because your first answer has 3 sig figs. Is there any questions about that? We only know those unit conversions. Those are the only ones we're going to use right now. Okay, so basically it's just in what order are you doing them? Okay, I would like you, not that, to do these questions, please. Practice questions. There's only 4 of them, and then I'll put the answers up, and then we'll move on.